Okay.
There you go.
All right. Oops, wrong screen. Can you guys see browser? Okay, awesome. Okay, so just quick about me. I'm currently a route, but I'll be in Entrada in a couple weeks. So at Entrada, I think my title is going to be principal data engineer. I'm going to be kind of doing data architecting stuff and just basically bouncing around trying to solve hard problems. I understand there's plenty of hard problems to solve there. So outside of coding and stuff, I like woodworking, photography, the outdoors, and I like playing pool. So I've been working on a book for the last couple of years. It's still in a work in progress, but chapter 3 is basically what we're going to talk about today. So it's basically this chapter here. So if anyone wants to take a look at that, feel free. It's just online. It's just at kludge.net. So all right, let's get started. So we're going to talk about Postgres, and we're going to talk about basically how Postgres writes data to its actual files. We're going to look at the files. We're going to see the actual content in the that's written to the data, or the data that's written to those files, and kind of see how it works under the hood. From the intros, I know everyone has some level of data knowledge. So some of this might be basic, some of this might be new. Hopefully everyone learns at least something tonight. But yeah, we'll start off with the ACID compliant notion of Postgres. Just off the top, who's familiar with this, like from Postgres or other databases that you've used? Like, does anyone not know what ACID compliance means? You guys can talk too. We can have a conversation. Okay. Well, I'll explain it a little bit. So ACID stands for atomic, consistent, isolated, and durable. That's a bunch of fancy words to say that Postgres isn't going to lose data if it crashes, and it's going to return the correct data. So at the time that you run a query, you're going to receive the data that it was at the time that the query was run. So even though like writes and reads are happening all the time, it's looking at timestamps, it's looking at those kinds of things to make sure that it returns the correct data. So let's talk about how it does that. The first step is it has a write-ahead log, which is known as the wall. And it basically, every write that comes in gets written to the end of this file. If anyone's used to like Kafka or anything like that, you may have actually seen this graphic before, because I actually stole it from Kafka's website, because it's exactly the same concept. It just writes to the end, and then any consumer reading off of it has a pointer. So a consumer might be like a read replica, or there's any number of things that can consume something like Debezium or whatever else, can be reading from this wall so that it can get the data that it needs. So that's the write-ahead log. Any questions or thoughts so far? Okay. Next step is the checkpoint step. So what happens is when there's enough data that is on the wall, but it hasn't been persisted to the actual files, a checkpoint happens. And this is usually based on either a timer or an amount of data, whichever gets hit first. I think by default, if I remember correctly, I think it's every 5 minutes. And I want to say it's like every 64 megs, but I could be wrong on that. Does anyone know off the top? Pat, do you remember this setting?
I'm pretty sure it went up after about 10. I think 9.6 was 64 or something, but 10 was higher.
Oh, okay. So so yeah, so once it hits this threshold, it takes whatever's on the wall and it just batch updates into the correct table files. So that's step 2 is a checkpoint. And then what happens is any insert, update, delete, any sort of write, when it's writing to the tables themselves, it writes the entire row again. So even if you're only changing one column, it writes the entire row. That's a row-based database versus a columnar. Columnars are different. The files are split out by column, where Postgres, it's row-based. So you change one column in there, it rewrites the entire row, whether that's an update or anything. So so that's very important when you're talking about performance, because you have a table that gets updated a ton, and you don't realize that, you're like, oh, I'm only updating one column in here. Why is this so slow? That's why it's rewriting the entire row. And that's based on the ACID compliance, because like I said, when the query runs, it needs to know what the data was when the query started. And so it has to maintain the old version of the row and any new versions of the row. Does that make sense? Any questions?
Not so far.
Awesome. Is this new at all, or is this like, oh yeah, I know this so much, you know?
I know it. One thing I will mention there is the hot updates change that a little bit, but not much.
Okay.
So when you're doing with a hot update, it doesn't rewrite the entire row.
Oh, really? That's
It
interesting.
does. It does. It's just in the same page, and it won't necessarily. It won't update the indexes to point to that new row version. It just points to the original row version, and that points to the new row version within the same page. So
Okay.
it's still a full page update. It's still a full row that gets written. It's just, if it can, it will fit it into the same page and not update the indexes.
Right.
Awesome. When did I'm unaware of this. When did these get added? Is that a newer?
Tuples have been around forever.
Okay.
Yeah.
Cool. All right. So the next step. So once there's enough, so every time there's an update that happens, the old row gets marked that it's old, basically, and it's marked that it's a dirty tuple is what Postgres calls it. And so by default, when 20% of the table has is dirty versus clean, it will do what is called a vacuum. And this is probably old news as well, but the vacuum will go through all those old rows, and it basically marks them that they're reusable. And so when a new update or a new insert comes along, it will rewrite over the top of those old, the old obsolete rows. So that's your normal vacuum. And okay, and then the last thing is it'll checkpoint again, and it'll rewrite. It'll start. So once it's vacuumed, any new checkpoint that happens will get rewritten over the top of the old rows. So I was ahead of myself a little bit there.
I have a question on the checkpoint.
Yeah.
I'm just comparing this with Delta Lake, basically. So in Delta Lake, like a checkpoint keeps track of when I last read or write happened on that particular table. Is it same thing here, or is it different? Because we use the checkpoint for basically for ETL purposes, like, what was my last checkpoint, and from that I used to read all the data for the ETL purposes. So is it something similar, or is it different here?
I think it's similar. I'm not sure, but yeah, the checkpoint, all it is it's saying what has changed in the wall since the last time. It's basically, the checkpoint is just kind of a placeholder in that wall file. So let me go back here. So maybe the checkpoint said, okay, I'm on 7, and now I've got 8, 9, all the way through 12. When the next checkpoint happens, it says, oh, okay, the last time I completed it was on 7. Go ahead and read 8 to 12, get all those changes, and then persist those into the actual tables.
Okay.
So does that make sense?
Mm-hmm.
Okay. Cool. Let's get to the workshop side of this then. So this is the end of the presentation. The rest of it is demo time. So is this screen, is this text big enough for everyone to read?
Looks great.
Okay, awesome. Okay, so Matt, you'll need to have some sort of way to query. It can be pSQL, it can be data grip or whatever. What program do you use for that?
I've just got pSQL on
Okay.
the setup I've got now.
Awesome. Okay. So so the first thing you want to do, just run the show data directory. So in my case, it's in let's see if I can make my results a little better because that's really small. My monitor that I'm sharing on, sometimes it starts to lag a little bit. If it lags too hard, I'll move it over to my laptop, but it's a little easier for me to move around on my monitor. So in my particular case, this is where Postgres is. Yours will be different. So what you want to do is change directory to this whatever your version of it is. In my case, I've got a space here, which is always kind of a pain. So I'm already in the folder that I need to be. So yeah, let me know when you're there. And then once you're there, change into base. If my user is myself, so I have access to everything. If it's Postgres, you might have to sudo as root, which is sudo. I think it's just sudo dash like that.
Okay. Yep, I'm in there now as root.
Okay, awesome. And then yeah, go into base. Base is where all the data actually is. And so you'll see a bunch of folders with random numbers. Awesome. So since we're staring into the abyss, we're going to create a database called Abyss. I just have drop, so because I've redone this a few times, so you don't have to run the drop, but run create database. And in our chat, let me see if I can get a chat window up. I'll copy these things in here so that it'll be a little bit easier to follow along as we're going. But create an Abyss database. I'm going to do that right now. Okay, and then the next step, and this one's really important because it's tripped up people in the past. Make sure you actually select or you check out Abyss. So in your case, if you're in pSQL, you're going to do \C. It'll look like C Abyss for anyone following along. If you're in pSQL, are you to that point?
Yep. Yeah.
Okay, the next query is this. And so what these random numbers are, they're OIDs, and inside Postgres, it has a mapping of that number to the actual database names. And so if we run this query, we're going to see that mapping. So I'm going to run that. And you'll see I have Abyss and it has this number. So in my case, it's 32,790. So let me look at this again because I've created that database now. I have a new folder, 32,790. So that's my database that I just created. So whichever one you're in, Matt, go ahead and change directory to that. And you're going to see a whole bunch of files already in there. These files, even though I don't have any data yet, Postgres comes with a bunch of stuff like system tables where they keep all their stats and like, you know, just kind of all the basic stuff that you just start out with because it uses itself to maintain all of its like query plans and all that stuff. So, so if we look at here, if we do this command, you'll see that there are, in my case, there's 293 files in here.
Same as me.
And then also, let's see, do I have the, oh, you have the same 293 files? That's awesome.
Yep.
Okay, cool. There's another command called OID to name that you can just run. It's not a pSQL thing. It does the same thing as that query. It's kind of a command line thing. So that tells you it's the same. Abyss 32, in my case, 32,790 is my table. Cool. Okay, so we don't have any actual tables yet, so we're going to create a table, but I'm going to pause for a second and just see if anyone has any questions or thoughts so far. Does this all make sense?
Can we drop some of those objects in the directory? It'd be a lot of fun.
No, thanks. That would, yeah. We'll do that when I get to Entrada with one of your. Awesome. So let's create a table, just a basic table. We'll call it customers. I'm going to throw that in our chat. Okay, it copies pretty well in there. That's cool. And let's go ahead and create that. So now if I run this again, I had 293 files. I now have 298 files. So it created a table, it created a sequence, it created probably a primary key is my guess. There's a few other files that it would have created. But you'll notice in here, if I look at these, everything's still just a number, right? It's like, okay, well, which table is actually, or which of these files is actually this table? So they give us a nice little command or a little query here. That will tell us. And so if I run that, it's telling me that it's in base, it's in 32,790, which is my database. And then 32,793 in my case is this customer table. So if I look in here, oh, and one other thing real quick, that OID2 name also, you can also use that. So if I run that here, it tells me 32,793 is my customer table. So if I look at that specific table, or sorry, file, I look at my number was this, oops. There it is, right there. So it has 0 bytes, it's brand new. Matt, here's you'll need to change the number to yours, but that's the command I just ran. So it has 0 bytes, obviously, because I just created it, there's nothing in there. So let's go ahead and insert some row and we'll see what happens. Here's row 1. I run that. I'm going to look at this file again. So the file size is 8192. There's no way that Brian, Salt Lake City, and Hey, It's Me is 8,192 bytes. Someone mentioned the keyword earlier. Why is 8192 important?
That's just one page.
There you go.
Block.
Excellent. So everyone understands a page in Postgres is 8 kilobytes, and everything is stored as 8 kilobyte chunks. And so even though there's not 8 kilobytes of data here, it's going to create a full page. Does that make sense to anyone on the call?
Brian, can you repeat the statement, last one? Sorry, I missed.
Yeah, so Postgres, it stores everything in 8 kilobyte pages. So basically what that means is it's able to scan it, and it knows like how to scan to specific parts of the file based on where what page it's looking for. So even though I've inserted just the text Brian, Salt Lake City, and Hey, It's Me, excuse me, it went and padded the full 8 kilobytes, and it inserted this, but it padded the whole thing. So let's look at the actual data in there real quick. So it's this number. Wait a sec. There's just zeros in here. Does anybody know why? Like, why is this still empty? I just inserted a row.
I would expect, because it hasn't been flushed to disk.
Bingo. You guys are good. Usually it takes people a while to figure that one out. Yeah, there's no checkpoint that's happened yet. So if we actually run a checkpoint, it will run like I said before. There's a timer and there's an amount of data. So if I had waited long enough, the data would actually show up. But if I go and run an actual checkpoint, and I look at this again, now you can see I have actual data, right? I've got my Brian, I've got Salt Lake City, and I've got, hey, it's me here. The rest of this stuff is basically mapping of the stuff in the page. I don't know what all the bits mean in there. We're going to look at basically the text that is human readable. So yeah, so does that make sense? Now that a checkpoint's happened, it read the wall, and it took the data that is new from the last checkpoint, and it's persisted it to this file.
So does it mean before you executed the checkpoint, it's all in the memory, or the data that?
It is in memory, but it's also written to the wall file. So with Postgres, to make it durable, back with that ACID compliance, the durability part, as soon as a commit happens on a insert statement or in a transaction, it has to have verified that it was written to the wall. And once it's actually, once that wall basically acts back and says, yeah, I've written this, then the commit will complete, and your query, your insert statement will actually return that it's done. So you don't actually know that it's done until it's written to the wall. And that's how, like, if Postgres, like, you pull the plug on it, you plug it back in, you turn it back on, and it goes through that recovery. It's looking at, like, what's in my tables, what's in my wall, what hasn't been written to my tables, and it's going to reread everything in the wall. So like, if you have a lot, if you allow your wall to get huge because of performance reasons and stuff, it can take a little bit longer to do the startup process because it has a lot more data that has to actually read. And because it go and read all that stuff, put all that back into memory, basically merge the two data sets together in memory before it's like, okay, I can actually run queries now. But then if the checkpoint happens, then it's actually writing all the new stuff from the wall into these actual tables, and then it can move forward. Does that answer your question?
Yeah, it makes sense. But one more question on that. So let's say if Kafka or some other things are reading from wall logs, right, to replicate the data. How does it know, like, I mean, once it runs a checkpoint, it means that it might not be in the wall logs. Is that true?
It'll still be in the wall. What happens is, so excuse me. So maybe the actual, like, the consumer that's taking the wall data and persisting it to this file here is just one consumer. If you have, like, a read replica or Kafka, or like Kafka Connect or whatever is trying to read from it, it'll be a different consumer, and that'll be at a different offset in here. So maybe Kafka connects at 5, but maybe the internal process is at 9. Whatever the oldest one is, Postgres will not delete anything older than that, which you guys have probably had this experience before, where you had a subscriber that died and it's been sitting there for a while and no one really realized it, and then your hard drive filled up. It's because it's not letting these wall files get deleted. Does that make sense?
Yeah.
So you go and usually in that case, you'd go and, like, kill that old subscriber, and then Postgres will go and purge off anything older up until the next oldest subscriber, and so you can free up that memory, or sorry, that storage on your hard drive. So does that make sense?
Yep. Yeah.
Yeah, so you can have many consumers. You can have as many consumers as you want, up until the point where your hard drive can't keep up, right? So okay, so we have some data. So let's add a little bit more data to make this a little bit more interesting. Did someone have a question? Okay, I heard something, but so let's add Robert from Paris. And let's add James from Bountiful. I'm going to run these two queries. Insert that. I'm going to insert this one. I'm going to run a checkpoint just so we can make sure that all our data is up to date. And I'm going to look at the data now. So you can see that James is in there, Robert is in there, and I'm in there. So it's just adding to that same page. You can also see from here, you can see from the 0 line all the way to 2000. Like when we look back here, we had 0 to 2000. That's basically just the padding for the 8 kilobytes. And so as we're adding data, it's still padded out to 2000. Once we have enough data that there's more than 8 kilobytes, it'll just create another page and just keep going from there. Matt, do you have those 3 rows in there?
I do. My James changed to James Cameron. I mean, this is the abyss, but other than that, everything looks the same.
That's actually, yeah, I hadn't thought of that. That's awesome. Okay.
Yeah,
I like it. Let's go ahead and move whoever ID 2 was. Well, let's find out who's ID 2. ID 2 is Robert from Paris. Let's move him to Chicago. So we're going to update that. And let me give you this query here. And there's our Chicago move. So now we have an update. We need a checkpoint again, or we won't see any changes. And I'm going to look at our data here again. So we got Robert in Chicago, and I've got Robert in Paris. So this is what I was talking about before, where it rewrites the entire row. It's not just rewriting the fact that I only changed Chicago here. Oh, and I changed move cities as well, but his name stayed. So it's actually in there twice. So, and then let's delete me from there. So we'll delete ID 1. And there's that checkpoint. And you'll see that I'm still in there. But some of this stuff has changed up here, and they're like a couple bits here or there has changed a little bit. But this data is still there, and that's again because of ACID. If there's a select running between, if it started before this delete happened, it would still return this row here. So let's look at our user table stats. Is next. Excuse me, one sec. Stupid cough. So the user table, have you guys seen this before?
Yes.
There's a bunch of columns in here. For this, I only care about 2 of them for this thing. So we're just going to select the specific ones. Here, Matt, let me do this to you. So you'll see, because I did 1 update, I did 1 delete, I have 2 dead tuples, and I have 2 live tuples because there's still 2 that, so I've got 2 dead and 2 live, because I actually deleted 1. So I originally had 3 rows. Now I have 2 rows. If I select this again, I should only have 2 rows that return, and I do. So does that make sense? Does that make sense, the difference between live tuples and dead tuples? Do you guys?
Yep.
Awesome. Thank you. Okay, so now that you've seen that, let's run a vacuum. And you'll see that this data, oh, I need a checkpoint. I just caught myself. So the data's changed up a little bit. See how there's up here, like there's different stuff here. There was Robert, James, Robert, Brian because of those. Now we've got a little bit like it's subtly changed. And what it's basically done is it has marked the dead tuples as overridable. And so if we run that query again to see our stats, it's now 0. So we had 2, now it's 0 because we're out of the vacuum. So let's insert one more row. William here. And run the checkpoint. All right, so we had Robert. We've got Robert moved cities here, so that's still in there. But you can see William has been written in. So see how it's slightly different. So we've got William and we've got James and we've got Robert. So it rewrote part of it. There's 2 dead tuples, not just one. So there's still a little bit of that stuff that's overwritable. And it'll get written over the next time, and it'll just try and like clean up after itself. So let's run. Oh, and then the last thing to show is so the difference between vacuum and vacuum full. Vacuum just kind of does it in the background. You can run it manually if you want, like we did. But it just tries to keep up after itself and clean up after itself. You can also run vacuum full. It will actually go and it rewrites the entire file from scratch. So it cleans up any of the old, and I think I need to run a checkpoint. Probably not, because it actually wrote the file. Oh, that's interesting. See how my old ID, it deleted that one. There's an actually new ID. So let's run this thing again. So now it's 32802 because it literally deleted the old one. So 802 here. And now I have a clean file with only the live stuff, right? So that's the difference between vacuum and vacuum full. Vacuum full locks the table. So if you're on a really large table and you're in prod, you're probably not going to do this unless you're willing to have downtime. But usually like the vacuum can keep up unless you have a table that gets updated a ton in a really quick fashion. Then you end up with bloat. But yeah, that's basically the end of the workshop. Any questions, thoughts?
Why should we not just vacuum full everything and keep it all clean?
It will lock your table, and so you're gonna have downtime. Like if it's something that can allow downtime, then great, go for it. Most things can't, so that's gonna be your issue there.
It's also a little bit fruitless because unless your activity on that table is going to change, you're going to continue to have bloat. The goal shouldn't be to have 0 bloat. It should be to have a steady state that is maintainable, that is reasonable. And so to tune auto vacuum such that it is keeping up and that it is doing, it's cleaning out stuff enough that new rows can find space in the existing pages.
Absolutely. Yeah. If you ever get to the point where you need a vacuum full, there's probably something you're doing that could be changed. Maybe you split out the table. Maybe there's one column that gets written to a ton. Like I've seen status columns, it goes from pending to complete or something like that. And it gets updated a ton, or like an inventory column on like a shopping cart that just gets updated a ton. Hit counters, like back in the day, they're not as cool as they used to be, but like those things used to get hit a ton. So moving that kind of stuff to its own table that kind of like isolates that, right? And so it keeps the kind of the main table from having all those updates, and is kind of one of those things that you can do instead of like resorting to vacuum full or whatever. But vacuum full is kind of like the, oh crap, we don't have any hard drive space left and we need to get some hard drive space, so let's go and like shrink a table or two. But it shouldn't be used as a normal course of like normal. It shouldn't be used when things are running smoothly, I guess.
It also requires enough space to rewrite all the active rows. So you may not even have enough space to do that. So
That's true.
there are other options as well.
That's true. Very true. Cool. That's
I have some comments. What this conversation makes me think about is, and again, I come from a SQL Server background, so forgive me for referencing it, but that's my point of reference. And I found that when I've been in DBA roles, I've tried to think of like, and the transaction log, right? The wall log, transaction log works the same way. Where if I'm going to shrink it, I'm only going to shrink it to the point where it's probably going to be comfortable at, right? And it kind of makes me think of the same thing when it comes to vacuum versus vacuum full, right? Like, what is the typical percentage of dead tuples in a given time? Maybe I'm totally thinking about it wrong.
So by default, it will vacuum at 20%. Anyone that's used Postgres for an amount of time will know that that's way too big on a large table. You think like a table with like 1 billion rows, it has to have 200 million changes before it's going to vacuum once. Like that's kind of ridiculous. But the reason why it's set so high is because Postgres has been around forever. I think they started writing it in 86, and back then, a few thousand rows was actually a lot. Like they weren't thinking millions of rows. They only had a few kilobytes of memory. So it was a different world back then. But so by default, 20%. And I believe you can definitely change the percent. I believe you can have an actual number threshold, and I think it's whatever hits first.
No, it's cumulative. So you say 1,000 rows plus 2% or whatever.
Oh, really? I thought it was an or. That's good to know.
No, it's not or.
Okay.
Does that 20% also have to do with the threshold for statistics? I've heard 20% as the statistics threshold as well. Is that kind of part of the same process that kicks off?
So the stats is when you do analyze on a table, it'll rebuild the stats. There's separate configurations, so you can have like 20% on your vacuum and a different percent on your analyze, but it's kind of the same thing. You want to have your analyze running more often because that's how Postgres deals with the query planner, and it knows that's how it's like, okay, I'm going to pick this index or I'm not going to pick this index, and it's based on those stats. So you want to kind of keep those as up to date as possible, but not too much that it's it's spending all these resources doing stuff on that. So there's kind of a sweet spot in there. 1 or 2% on a table is probably good, but every table is going to be different. Every use case is different, and so as part of our jobs as DBEs is like figuring out what that actually should be, and kind of tune it to what that particular project is. So
one more question, and this might be kind of more oriented around people who have worked with a lot of different RDBMSs. I'm curious if the MVCC aspect of Postgres causes the architecture sometimes to be implemented differently, right? Like if I do it this way and have a DML workload like this, then it's going to result in a table that's super bloated. But if I do it that way, it's going to reduce bloat, and it's a little bit different because you're using Postgres. Do you guys see anything like that in Postgres?
I've got an opinion on it. I'll let Brian go first if he wants.
Yeah, go for it. I've been talking for an hour.
Jacob, I would definitely say I haven't seen that because I haven't seen someone deep dive enough to understand the MVCC versus snapshot versus something else for Oracle and so forth and so on, because like we talked about earlier, is they really just design based on ORM, not necessarily trying to redesign the entire architecture based off the database. Rarely do you find apps that are architected with their databases in mind, because they really just architect off an ORM. They don't care.
What's an ORM? I'm just kidding. I'm just kidding.
Yeah. I don't know, Brian, what's your thoughts on that too?
No, I agree with that. Most app developers are focused on the next feature. They're less inclined to pay attention to the database, which is why I think we all have jobs. So
What I will add there, Brian, is, I mean, Jacob, is that I have heard people talk about the Oracle's differences of how it does row IDs and this version control, and how Postgres and then how SQL Server has snapshot. I've definitely heard them compared and discussed, but it's always at the database level. It's always between us and everybody else here that understands it. It's never, the app designers never care what that is. They barely understand it. They just say, well, just write it how I want to write it.
I've just found myself asking myself that question, right? Like if I was to take up a passion project, for example, and decide which database to use. If I was to choose Postgres, would I try to manage bloat through the architecture in addition to vacuuming? And I don't know the answer for myself, but I'm just curious from you guys. That's why I ask.
I don't know if, like, at that point, you have to have a pretty massive project to care. If you're dealing in billions of rows, then it might make sense. But I think, like, for anything smaller than that, like having a little bit extra bloat in a file is, you're not going to notice it, I don't think.
What I'll say though is, I will say that I bet you would, because you're a database person. It's in the back of your head that someday you're going to have to deal with bloat and you don't want to. So,
well, it's a good mindset to be in, I think, as a person who's influencing the data architecture.
yeah, for sure. I mean, I think that's the part of it, Jacob, is that you're definitely influencing, and that's where we need to bring those conversations to the other people to say, you need to think about this. Now that you have designed your apps, you've done these things. Now we need to think about this to make it better. I know Brian's experience from Podium is that we made a lot of those changes. He made a lot of those changes that were update one little row, and that had a big impact on a lot of things, because we had that pattern in a lot of places.
Yeah, everything was update one thing, insert one thing, select one thing, and just the simple fact of changing it from that to dealing with more like a batch. We saw massive improvements on things. There was one specific instance where it was about 140,000 times faster, just going to batch versus doing things one at a time. So yeah, anyway.
All right. Well, any other final questions? I mean, I don't want to cut off early. I just want to see if there's any other questions going on. All right, I don't think so. For right now, no matter what, I'm going to go ahead and stop the recording. So we got that part done. Brian, excellent presentation. Thank you very much. Hopefully everybody got something out of it and did learn something. I'll go ahead and stop the recording now.